Hey everybody, welcome back. Today we're working on the front shock travel sensors for the Valiant, and got a plan, I think, of how I'm going to do it, and I'll just take you over and kind of show you the idea, and yeah, we'll see what you think. So here's the front suspension. As you've seen in lots of my other videos, I've got rid of all the torsion bars and stuff that came in it from the factory. I put this system in it, and this was made by a company called Gerst, who developed this whole K-member and coilover stuff. And now I think Gerst has sold the setup to QA1. But anyway, I've got some coilovers in here with Viking double adjustable shocks, and what I want to do is I want to mount one of these Rife shock travel sensors. And so what I think I'm going to do is I'm going to manufacture a method to hold the sensor up here. Basically, it'll get mounted to the center point. Let me hold the camera straight. It'll get mounted to the center point of the shock mounting bolt. I got a couple ideas on how to do that. And then on the bottom, down here, I'm just going to basically make an L bracket that comes off the bottom shock mount. And I'll space this out so it's about at least a ½ an inch away from the spring. So there's, it'll never rub on anything like that. And then I think just to keep some of the dirt and grime out of it, I'll probably turn it upside down and have the sliding end up at the top. So yeah, that's kind of the plan. So I'm going to start making some mounts to mount these shock sensors, and we'll get going on it. Hopefully by the end of the day I'll have those on, and I can proceed on with some the rest of the stuff, like getting the motor and transmission and stuff in. So I'll bring you back in a bit. Okay, so figured I'd show you what I kind of got going on here for an idea. I'm going to make an aluminum adapter that slides over this bolt, and when the bolt gets tightened it'll capture it, and then there'll be a screw in this end, and that's where this piece will mount to. It'll basically just kind of go like that. And thought about making just a piece that welds onto the end of the bolt, but I don't really want to weld on the bolt, and then you got custom bolts, and if you need something on the road or whatever. So I'm just going to make this aluminum adapter, and it's basically going to have a slot in it so that it'll slide over the bolt, and then another slot on the other plane so the head of the bolt will fit into it, and then I'll just thread this end of it, and that's how we'll do it. So basically just come over here. I've got some aluminum bar stock, and just come over here to the cutoff saw, and we cut off a chunk a little bit longer than I think I needed, probably 1/4 of an inch longer than it really needs to be, but by the time I finish the ends and stuff in the lathe and get done making it, it'll probably get shorter. So I've got it set up here in the lathe. First operation was just to face off this end, and I just took the finish off of it a little bit, just cleaned it up a little bit. So now what I'm going to do, I'm going to go over to the mill, and I'm basically going to mill a ½ inch slot in the thing this way. So it's just going to have like a groove in it that the bolt will slide into, and then I'll reposition it in the mill 90 degrees from that, and I'll mill another slot back here for the head of the bolt to fit into. So let's see if I can set this camera down where you can still see something. Yeah, sorry about that. So basically we're going to have one slot that goes in it from this end and then another slot that goes in it this way. And I'll record some of it on the mill. I'm not going to record all of it because milling video is, I'm told, pretty boring for those of you who aren't machinists. But anyway, that's kind of the plan. And then once we get the bolt to fit in it properly, then we'll turn it around, taper this end, put a hole in the end, thread it, and should be ready to just bolt on, just kind of like a big washer. So that's the plan. Okay, so first thing we're going to do, I have the piece of material set up in here with a V-block. So I got good 3 points of clamping. And first thing I'm going to do is find the center of it. So we use one of these, I call them wobblers, and we'll look for the center. All right, so there's that edge, and we'll just zero out the DRO, and then we'll move over to the other side and find the edge on this side, and we'll take half that and we'll be there. Right about there. So if I take 1/2 of X and this is telling me where the center will be, but before I get this all dialed in on center, I got to put my end mill in there. I'll take out the wobbler. And I'm using a 2-flute carbide end mill. Give that a bit of a grunk. Okay, so now we watch the DRO and we find center. And the DRO is telling me that center is right there. So now what I got to do is just machine a slot in here about 9/16 of an inch deep. And because I have more clearance on this side than I do on this side with the block in it, I'm going to do it from this side. So I'm just going to back this straight up, raise the table some. And I'm going to find my touch-off point and set my quill height to 0. Right there. So that's 0. So I'm going to go 9/16 from there. So 9/16 in real numbers is 0.565. So I'm going to come down 0.565 eventually, but yeah. So here we go. We'll put a little shmoo on there. And come down. Check my 0. Yep, looks good. I'm not too worried about the 0 on this axis, but we'll get that set up as well. we'll just kind of rinse and repeat till we get to 0.565. A little bit more here. You can see I've got some aluminum building up on the mill, so we're just going to knock that off. Clear the chips out apart. Okay, we're at 250, we're almost halfway. Rinse and repeat. Okay, we're going to go to 300, 350. So you might hear it kind of crunch a little bit every once in a while, and that's, I think, because I'm basically fine milling on one side and conventional milling on the other side, because the direction of the mill is different side to side, right? So, and I think also the chips get bound up in there, and that's part of it as well. I really should have like flood coolant or at least a blower or something on that, and I don't. So just gotta be careful and, you know, see where we are here. I'm going to measure this real quick and just kind of see how deep we are. Let me get my blowgun. Okay, so we were looking for 565. Whoops, I can't really go out any farther than that, so we'll see if I can make that work. Yeah, we're at 465, so I need another 100 thousandths. I'll make sure that I don't run the mill into the jaw on the vise. Oh, I think we'll be okay. So we'll just run this down to 560. And we're still missing the jaw by a fair bit. So this should be the last pass. I'm just going to blow those chips out of there. I'd like the last pass to be smooth and not have too many marks in it, so okay. So that's that one done. So now what we'll do is reorient this in the vise, turn it sideways, and we'll put a groove in it this way for the head of the bolt to fit down into. And we'll use a different size mill and stuff. So I'll get that all set up and I'll bring you back. Okay, so we got that set up. The only tricky part of this is getting it in here so that the groove that I'm going to make is 90 degrees to this groove. So what I do is I take the end mill that I use to cut this groove, put it in here, and just put a little bubble level on it like that, and just make sure that everything's level. I actually use this end of it, but anyway, so I've got it in there. Everything's level, everything's good, and well, take my word for it. It's good. I've checked it 3 times. So I think now we're just going to drive. This is a 5/16 end mill, and that's the thickness of the head of this bolt. So we're just going to make a slot in there, and then the bolt will slide in. and on the other end we'll drill and tap it, and Bob's your uncle. So here we go. I'm going to clear those chips. And we'll check it for depth. That might be deep enough. We'll have to see here. Just move the table out of the way so I can test fit the bolt. Blow some chips out. Machining is a messy business. So I need to make the opening just a little bit wider. That's okay. That's pretty straightforward. So if we know where our zeros are here, I'm just going to move the table about, I'd say, let's move it about 50 thousandths. And we'll just take about 50 thousandths off of this wall, sort of the washer wall, and see what happens. This is probably going to chatter a little bit, but it's a pretty light cut. Oh, no, yeah, I figured it would chatter some. Okay. Well, let's try that bolt fit again. Yeah. That's what we need, just like that. So that'll just clamp on the shock, and the other end of this is going to get threaded and tapered and cleaned up, and yeah, done. So pretty happy with that. Obviously it needs to be cleaned up just a little bit, but that's pretty good. So when we get back in the lathe and I'm working on the other end, I'll bring you back over there. All right, well, we'll begin by facing this end off and getting it nice and square and true to the world. Still got a little bit of a saw cut in it right there, so we'll take another couple of thou off of that. Call her good. I'm using the cross slide feed, the automatic feed on the lathe, just because this is going to be a finished pass, and it just makes it really consistent and smooth. There aren't any sort of threading marks or, what you'd call, grooves. It doesn't look like a record album or something in the end of the piece of aluminum. So it's a pretty slow feed. Can't remember exactly where I've got this thing set, but it's something at like 3 thousandths per revolution or something like that. So it's pretty slow, and as you can see, the chips are really fine, but does end up with a really nice finish, which is why I like it. I just realized something. I kind of got the cart before the horse here. I should have checked for final length. I may have to take 1/8 of an inch off this thing yet. I gotta check it for final length, but I can do that when I taper it too, so I guess not a big deal. We'll see how well I have my tool post height set. If it's set properly, there should be no little tiny nub or nothing at the center of that piece of material when we're finished. It should be basically perfectly flat. So we'll see. It looks pretty good. So tool post height, I guess, is good. So let me just check the length that this needs to be. If memory serves, I wrote it down over here someplace. It's got to be like 1.3 inches long, and this one is 1.45. So I do need to take let's see, I probably need to take fair bit off of it, but that's okay. We can take that off in a couple of passes pretty easily. And it's also not a critical measurement, so don't have to worry about it. But I'll show you what the difference is. If you see here, we've got a really nice smooth, it feels polished almost finish on that. I'm going to do a manual pass just to shorten this up a little bit, and you'll see how that looks. You see it's got grooves and marks and stuff in it where I wasn't consistent and stuff. So that's why I use the machine's automatic feed. It just does a better job. And plus I can just stand here and watch it. I don't have to worry about turning the dial myself. This is the opportunity where I use the fast forward mode. Okay. Now we have our choice of operations. I can either drill it and get it ready for threading, or I can put the taper on it. And since I'm already set up here, I think I'll just go ahead and put the taper on it. So basically what we're going to do is we're just going to put I think it's about a 15-degree taper on this thing, just to make it look a little bit nicer and make it look a little cleaner and stuff when it goes on the car. So by the way we do a taper is I have this compound slide set up at 15 degrees off of the parallel of the main lathe bed. And so what I'm going to do is I'll set this up, and then I'm going to use the infeed here on the cross slide, which is going to drive the cutter at a 15-degree angle to the workpiece. So that's kind of the way this works. I'll show you how it happens. And I use the cross slide to feed the cutter into the work. And it just cuts a taper. I'm taking small cuts because this isn't held in the jaw of the chuck all that ruggedly, and I don't want to mess that up. So I'm just taking small, light cuts. Don't put any force on the piece of material in the jaws, and just not taking any chances. That's looking pretty good. Take a couple of quick measurements here and just kind of see where we are in terms of just that general diameter. 8885. Okay, well, that's not out of the ballpark. So I think we'll probably call that good, and then we'll put some holes in it. So one of the things I like to do, just to gives a little more finished look, I think, is I'll put a chamfer on this corner here, and I'll just basically use I'm not even going to change the angle of the compound. I'm just going to run it in and just kind of take the edge off of that piece of aluminum, and just make it look like we actually meant to do that, right? So let's just see how this goes. Okay, I'm not exactly sure what happened to the camera, but replaced the battery, and that's the result of putting the chamfer on the piece. I just wanted you to see that. I think it looks pretty good. So now we're ready to take this tool out of the lathe, and we're ready to do some drilling. So just run the cross slide, get everything back out of the way, because I'll bring this table down fairly close so I can slide the tailstock in. And I need my center drill. Okay, center drill is loaded. Slide that into place. Like so. Lock the tailstock down. So the reason we center drill on stuff like this is to just make sure that when we drill the hole for the threads, everything goes straight. The drill bit is in the center of the workpiece where it belongs, and so on and so forth. Technically, I don't really have to center drill this, but I think it just does a better job, and it's one less thing to go wrong, and so on and so forth. But that's just me. I like to move in and out, break the chips when I'm center drilling. I find if you just try and drive the center drill like all the way down into the tapered section too soon, it tends to break the tip off the center drill, so we don't want to do that. I'm just going to put a little bit more, because that'll give the hole for the threads a bit of a chamfer, kind of automatically. We'll move that back out of the way, and we'll take this drill bit out, and we'll put our drill bit in for the, this is going to take a 1024 screw, and I'm just basically going to drill right through it. There's no need to make this a blind hole. There's nothing on the other side except a bolt head. The screw that goes in here won't ever go that far. It's just easier to tap. There's a place for the junk to go. So yeah, that's the plan. I'm just going to drill right through this. This is a number 22 drill bit. Break the chips. Clear the chips out. Could squirt some WD-40 in there, but it is not worth it for so small a crowd. Okay, I'm through. And that's that. This part now is ready to be finished. I'm going to put some threads in it, and I'll kind of show you how it works. So the way this works is, here's the shock bolt. It goes through the bracket. This slides over top of the shock bolt like that, and when I tighten the nut to hold the shock in, it clamps this thing in place. And then I put a screw in here, and that's where the sensor for the drive shaft, or the shock travel sensor goes on there, and Bob's your uncle. Now, I think what I'm going to do is I'm just going to hog out a little bit more in there. I'd like this bolt to fit a little bit farther in there. You can kind of see where it is. So what I'm going to do is I'm just going to take that end mill that I had set up in there and just kind of hog out a little bit right there in the middle. Just make the bolt go in a little bit further. It's not critical. It would work perfect just the way it is, but I'm just going to, just a minor improvement. Okay, tapping something like this is dead easy, but and I usually use one of these things, which keeps your tap square with the end of the piece of work. Now, this piece of work is so small that, I don't know how much help it's going to be. I'll use it anyway, but, just one of those things. If you're tapping holes on a bigger piece of material, it really helps. I put some, you can probably see, I've got some green stuff on here. That's, see if I can get it in the camera, anchor lube. And I like it for all kinds of metalworking stuff. It's water-based. It doesn't burn or anything like that. And so we're just going to run some threads in this thing. And using my Starrett T-handle, and I'm not sure what brand of high-speed steel tap this is. Let me see. This is Cleveland. I buy my taps in kits, so, and I'll show you what I mean when I get, so I'm far enough in the hole now where I can take this out and get rid of the guide, because I'm not going to go crooked now that I've got 1/2 inch of threads in there. But I will take the time to clean off the shmoo out of the tap and the shmoo out of the hole. I'll put a little bit more anchor lube on it, and that's actually way too much, but that's how much came out of the bottle. So aluminum is such nice material to work with like this. It's just, it machines nice, it taps nice, it does everything nice, and whenever possible I like to work with aluminum. I'm not really good at welding aluminum yet. I mean, I can weld it together and it'll hold, but it's not going to win any beauty contests. Takes a fair amount of skill and practice to be able to be good at welding aluminum. And so if you watched my video where my buddy Rick welded the two pieces of my console together, you'll see what I mean. Like, his welds are really nice. They're consistent. They're just a professional weld. And if I would have welded that, I could have welded the two pieces together and I could have used them, but it would never look as good as he did. And that's just practice. It's like anything else. You want to learn to play the guitar or play drums or whatever, you just got to practice and stay at it. And welding is the same way, especially TIG welding. MIG welding is not too hard. Almost anybody could learn to MIG weld in a day or two, like basic MIG welding. But TIG welding is a whole other deal. So there you go. So there's the hole, and the piece just needs to be cleaned up and polished a little bit. And I want to put a little chamfer on that hole. I just use, like, I've got this little Noga tool here, and I'll just run that in there like that, and gives it a nice little chamfer, smooths the edges and stuff. So that's basically that. Oh, I was going to show you the taps I use. So when I buy taps, I tend to buy them in a set like this. So this is 1024, and it comes with, a basic tap, and then, like a gun tap, and then a bottoming tap, And so, you doesn't matter what you need to do, what kind of a hole you've got taps. And I just buy these sets. I used to buy them, I'd get a set of taps. Well, they're expensive. Like if you wanted to buy a good set of high-speed steel taps that go from, let's say, 632 to half an inch and include pipe taps, you're looking at $600, $700 just for the taps. And that doesn't buy you 3 different kinds of each size. That's just one of each size, right? There's no bottoming taps and stuff in that. So anyway, that's the way I do it. It's not the only way to do it. It's not necessarily the right way to do it, but it's the way I do it. So now we're going to clean this piece up, make it look like something, and give it a trial fit on the car. Okay, so we've basically got the upper one built, and it's going to work like this. I can hold the camera with one hand and put this on with the other. So it's going to go on there, and this bolt's going to tighten down, and it's going to hold the top of that like that. So now down here on the bottom, down there, what I'm going to do is I'm just going to use some angle aluminum like this, and I'm going to cut a bracket that is basically the width of this shock base, the width of that pin, which I think is like 5/8. So I'll cut a bracket that's 5/8 wide, and then I have to trim it because this is all I've got for this stuff, and it's too long in both directions. So I'll trim it, make it fit, put 2 holes in it, thread it, and should be good to go. So these turned out to be way easier to mount than I expected. So I'm happy with the way this works. This is going to get held in place really nice like that. I've got to put this is not assembled, obviously. So when the shock gets installed in here, obviously there's these little angled washers that go in on each side of the shock, and self-locking nuts. So I've got those kind of all down here, and then I think the nut for the shock for that bolt, yeah, it's here somewhere as well. But anyway, that's kind of the plan. So we'll bring you back when there's something else worth looking at. So there are the finished parts. Just took them out of the sandblaster. It turned out pretty good, and they work really well. I've trial fit all of them, and everything works. These are the little angle brackets that I was making, as I mentioned before, just out of a piece of, angle aluminum. And so everything's done, ready to go, ready to install. And so now we can go and bolt one onto the car. So there it is. It's attached on the top, shock's all bolted in, and attached on the bottom. And one thing I like about it is the angle of the travel sensor is almost exactly the same angle as the shock. So the information we get from it will be really accurate to actual shock travel. So that was fairly easy. There's still some work to be done and stuff, but once we get some weight on this thing and get it jacked up, and things will be coming along. So I'm going to bolt the other side on now, and then we're going to move on to something else. I want to thank everybody for watching. I appreciate it. I'd love to hear from you. Leave some comments down below, and pretty soon we're going to be putting the motor back in this thing, and we'll get that on film as well. And I'm looking forward to it. I'm just anxious to drive this thing. So anyway, Thanks again for watching. I appreciate it. We'll talk to you soon.